Hello class, and welcome to lesson 6.1. Today we're going to be, actually unit 6, we're going to get into different parts of the problem that we haven't taken a look at. Just remember in unit 5, although it was a long unit folks, we did a lot of algebra, we did a lot of factoring, and that was to focus on the zeros or the x-intercepts. We did a lot of solving. This unit, ladies and gentlemen, we're going to be focusing more on the vertex and different parts of the quadratic function. We're actually going to learn how to switch to different forms in Unit 6. Please be reminded, folks, that also we did a mini Unit 4. It will also be tested with Unit 6 combined. So we're going to take a look at what we learned back there on the graphing calculator, different things of that, and we're going to apply it into Unit 6. So use Unit 4 as a stepping stone to help us with Unit 6, and they're both going to be covered on the next assessment. All right, so let's get started here, folks. 6.1, revisiting quadratic functions. So it says example 1, we're going to use the graphing calculator, whereas example 2, we're going to learn how to do this without the graphing calculator. So first thing we need to do is remember with a graphing calculator, if you've got one or an online graphing app, pull it out. Go to wherever it says y equals, and you're going to enter the equation. So I'm going to flip over to my graphing calculator. I'm going to go to y equals, and I'm going to enter my equation, which is x squared plus 2. Okay, and then I'm going to press enter. Okay. And ladies and gentlemen, on my screen you can see a graph as well, but if you need to, you can just press the graph button. Okay, so that looks exactly like the picture that you have in your lesson. Okay, so we've entered our equation into y equals. Now we have to recall different parts. So I'm going to go back to the lesson. I apologize for the first one. We'll be flip-flopping a bit. Okay, so the first one is the vertex, ladies and gentlemen. The vertex is the turning point on your graph. Okay, so if it goes down to a certain point and then it turns around and it forms a mirror image. Please do me a favor, folks, and put arrows on your graph there because it is a continuous function. So to find the vertex, ladies and gentlemen, we have to use either, in the graphing calculator, there's a menu, and the menu is second and trace. And then we got to decide in the menu part which avenue we're going to use. In order to find the vertex, you need to either know if it's the maximum you're going to find or the minimum. Let's quickly review, folks. The direction of opening affects your maximum or minimum. So in this case, ladies and gentlemen, we say it opens up, which in fact, folks, will answer one of these questions right here. So you can fill that in. It opens up. And if it opens up, folks, remember, these continue as we go up and left, and as we go up and right, they continue. But it comes down to a minimum. So when it opens up, you have what's called a minimum. So that will answer this question right here. Okay? And to find your vertex, we have to go second trace and press minimum. So I'm going to go back over to my graphing calculator. I'm going to go second and trace, which is my calculate menu. Okay, just give me a second. I got to go second and trace. Okay, and I said we wanted to find the minimum, which is 3. Now this is where you do the left bound, right bound. So you go on the left side of the vertex, which is there. Hit enter, go to the right side of the vertex. Hit enter, it'll say guess. And it'll give you a vertex. Oh, folks, do me a favor. Sorry, let me change my mode for a second. To float 2, and it'll change that for us. The reason why it went to scientific notation is because I didn't set to 2 decimal places. So now let's try that again. So I apologize. Second trace minimum 3. Left side. Get on the left side of the vertex. Hit enter. Go to the right side. Hit enter. It says guess. Okay, and there's our vertex, folks. 0 and 2. So I'm going to flip back over here. And I'm going to say vertex is 0 and 2. Just remember, folks, that tells us, remember, vertex is P and Q. So it tells us that the P is 0 and the Q is 2. All right. Axis of symmetry, ladies and gentlemen. If you think about the axis of symmetry, it's a mirror image, and it goes through the vertex. Hopefully you remember that from Unit 4 when we took a look at that. So this is the axis. Okay, and it actually relates to the first part of your vertex, so the P. So for the axis of symmetry, I want you to remember that it's x equals P. We already know what P is, it's 0, so that means x equals 0. So the mirror image comes in, hits the x-axis at a value of 0. Okay? All right, to find the y-intercept, ladies and gentlemen, we usually let x equal 0. So we're going to go to our menu on our graphing calculator, go second trace, give a value, which is number 1, so press enter, where x equals 0. So you enter that in, and it's going to tell you that y equals 2. So that's our y-intercept. So our y-intercept, y equals 2. All right. And to find your x-intercepts, ladies and gentlemen, another word for that, which we use in the calculator, is the zeros. Okay, but I want you to take a look at our graph, ladies and gentlemen. Do we have the graph ever touching the x-intercepts? We don't, but later on in your lesson, when you're going to be using an online app, I want you to realize that those are the zeros that you're going to be looking for. Okay, so in this case, according to this example here in this graph I have, we're going to write down NA or none. NA means non-applicable. Okay, why is that? Because it does not cross x-axis. Okay, awesome. Okay, the next thing we need to take a look is our min or max value. We already discussed it was a minimum, but I want to make sure you understand that's called an optimal value. So an optimal value is, hey, how low can we get? We already know it's a minimum. So the lowest part we can get, according to the graph, we have -2. But again, we can use the graphing calculator to prove that. So again, we would take a look at doing the minimum. So second trace, minimum again, okay, go to the left side, hit enter, go to the right side, hit enter, okay, guess, and again, that's our vertex, and we know that it's the y value, which is really the q when you think about p and q, so that is our minimum value. That's as small as we can get. So when I go back here, folks, you're going to say a min of 2, and in brackets I'm going to put down when x equals 0. Okay? All right. Okay. Now, the next one is called congruency, and that is related to the step pattern. So we know the step pattern is a times 1, 3, 5. In our base function, if a equals plus or minus 1, either positive 1 or negative 1, then our step pattern is going to be the same, which means it keeps the same shape. But that's what congruency is. Okay? So another word for congruent is asking, is the step pattern the same? I want you to think about that. All right. Well, two things we can do. Number one, we could look at the equation. And looking at the equation, what is A? A is the number that's out front of x squared, and it's a secret or a silent or a coefficient of 1, guys. Okay, so A equals 1. Does that tell us that our step pattern changes? No, it keeps it the same, right? Because A times 135 is still going to be 135 when you sub A equals 1 in. That's one way you could have done it. Or on the graph, start at your vertex, and as you go over 1, notice you go up 1. Over 1, up 3, and then you would have done your next step. So that indicates a step pattern. Okay, so therefore you're going to say yes, it is congruent because A equals 1. All right, so let's just quickly point out the things that I want you to remember, folks. The vertex is always going to be either at a minimum or a maximum. In this case, the vertex was x first, which was 0, and y, which is 2. Direction of opening is based on the sign of A. Okay, if A is positive, it opens up, and if A is negative, it opens down. That also relates to if it's a minimum or maximum. In this case, it opens up, so it goes to a minimum value here at the vertex. Okay, and the optimal value occurs horizontally, which is our red line here. It's our optimal value. And then lastly, folks, our mirror image, or our axis of symmetry, folks, is also going through the vertex, but it's going through it vertically. Okay? All right, let's try the second example without the graphing calculator, ladies and gentlemen. Okay, here's example 2. All right, so for example 2, we're going to take a look at the vertex. First of all, do me a favor, please. Can you put arrows on the graph? Thanks. Okay, vertex is the turning point. So I see a turning point right here, and we have an ordered pair of 3 and 1. So that tells me the vertex. I use V for just capital V, meaning for vertex, 3, 1, so you can recognize you're at the vertex. Okay, direction of opening this, folks, ladies and gentlemen, what is it going to be? It is actually going to be down. It's going to open down because A is negative or is less than 0. Okay. Axis of symmetry, hopefully you remember the same thing, that it's x equals p. So our equation is going to be x equals 3. Let's take a look, ladies and gentlemen, as I draw a vertical line through the vertex. Where does it hit the x-axis? At 3. Okay? That tells you your axis of symmetry. All right. Now, these ones can be a little harder, but we're going to do some inspection first, and then I'm going to show you down below how to actually solve these. Okay, so to find the x-intercept, remember you let to find the y-intercept, you're going to let x equal 0. Okay, so if you're going to let x equal 0, we look on the y, and visually, folks, it looks like for the y-intercept that it's negative 3.5. Okay, I'm going to show you how to actually solve it, and this is where you're going to use your tools from last unit. We know the equation. I'm just going to do it down below here. We know the equation is y equals 0.5 x minus 3 all squared plus 1. If we want to find the y-intercept, we're going to let x equals 0. So I'm going to solve this now by subbing in the value of 0. Just let me throw it in a different color in a second. So for every see an x, I'm going to put a 0. So let's do the mathematics behind this, folks. Okay, what is 0 subtract 3? That's negative 3, and then you square it is going to be 9. So it's going to be y equals negative 0.5. Negative 3 squared, we said, was 9 plus 1. If you take negative 0.5 times it by 9, that's negative 4.5 plus 1. So y equals negative 3.5. And that, in fact, is the answer that it looked like by inspection. Okay? All right. So next one, ladies and gentlemen, is to find the x-intercept. So we're going to visually look on the x-axis, and visually it looks like we got x equals 1.5, and it also looks like we've got x equals around 4.5. Okay, but I'm going to show you how to use the graphing calculator on this one quickly, and then I will show you how we learned last unit how to solve it. Okay, so let's flip to the question, go to to the graphing calculator. Let me plug this equation in first. So negative 0.5, opening bracket, x minus 3 squared plus 1. Let's just make sure we got a nice graph there. Okay, that's it. Just 1 second. All right, class, sorry about that. So we've got our graph here, folks, and now we want to do what's called the zeros, right? So if you have an online graphing app, we're going to look for the red one first. So in order to do that, we need to find what are called the zeros. So go to your calculate menu, which is second and trace. Okay, I'm going to remove that red dot. Oh, actually, it'll come back in a second. So I'm going to look for the zeros, which is number 2. Okay, now you got to be on the left side of that. So left side of that is as long as you're on the left side of the red dot. press enter. Right bound. This is where you got to be careful, guys. You got to be on the right side of the dot, but you got to be before the vertex. So anywhere here or here is good. Okay. As soon as you go on the other side of the vertex, it's going to get confused with the other 0, which we will call the blue dot there. Okay. All right. So let's take a look. We're going to press enter. We're going to say guess. And it gave us 1.59. So the actual answer, folks, was 1.59. We'll remember that. Let's do it the blue 0 now, the one that's in the blue dot. So you got to do it again. So go to your menu again, which is second trace. Okay. Go to zeros, which is number 2. Okay. This time when I do the left side, I have to be past the vertex but ahead of it. To be on the left side, press enter. I'm now going to go down and be on the right side. It says guess. And the other one is 4.41. So we are close, but not exact. That's why you have to do the mathematics behind it, because the graph itself does not give you the actual answers. Okay? So the actual answers are x equals 1.59 and x equals 4.4. I think we said 1, right? Okay, we'll double check that in a second. Now I'm going to show you how we learned last unit to do this. Okay? So here's my other way of doing this. To have the x-intercept, you're going to let y equal 0. So we're going to have 0 equals negative 0.5 x minus 3 squared plus 1. We're going to work backwards, ladies and gentlemen. So we have to get x by itself. So first thing we're going to do is take the plus 1, bring it over, becomes negative 1. Okay, so it's negative 1 equals negative 0.5 times x minus 3 squared. Okay, we are then going to get, we want to next get the binomial squared by itself. So we're going to currently it's multiplied by negative 0.5. So we're going to do the opposite, which is divide. Okay, and when you use your calculator, ladies and gentlemen, you notice a negative by a negative is a positive, and 1 divided by 1/2 is 2. So you've got 2 equals x minus 3 squared. And now we're going to remember we've got to take care of that exponent. So you got to do the opposite of squaring, which is square rooting. So whatever you do to one side, do the same to the other, and you take the positive or negative root. So we're left with plus or minus root 2 equals x minus 3. Bring the negative 3 over to make it positive, so you can isolate the x. And then, ladies and gentlemen, you break it into its 2 cases. So here we have x equals root 2 plus 3. And you plug that in your calculator, folks, that's going to give you the one of the answers. And x equals negative root 2 plus 3. That'll give you the second answer. So the first answer here, ladies and gentlemen, if you're plugging in your calculator, you should get 4.41. Okay, and the second one should give you 1.59. All right, that's just another method of doing it if you didn't have a graphing calculator to access. One thing I want you to write down before we flip the page, and I know I've gone over the space that you have here, folks, is what I want you to remember. The vertex P and Q gives us some important things. Okay, P gives us the axis of symmetry, and the Q part gives you your min or max value. And that's all part of the vertex. And remember, folks, another word for min-max value could be optimal value. All right, folks. Here is your homework today, folks. Okay. So what I want you to do, folks, is on page 291, if you have a mobile app or a graphing or online calculator with a graphing application, plot these and try to figure out them using a graphing app, and then after do 1 and 2 for homework without the calculators. All right, folks, have a great day, and we'll see you later.